Okay, good afternoon, folks. And first of all, thanks for joining this talk. And so today I'll be presenting on MariaDB Galera cluster best practices, but the same can be applied to Procona ExtraDB cluster because it also uses Galera as the replication engine. So my name is Nirbhay Choubey, and I work for MariaDB Corporation. And my primary job is to actually work on MariaDB Galera cluster besides working on some other parts of the server. And okay, so before we begin, I just wanted to share this quotation from Mitch Hedberg. He's an American comedian, and I felt that this suits quite well with the expectation that one has from a distributed system. So, yeah. Okay, so just to begin with, I just think I should just dive into a quick introduction of MariaDB Galera cluster. So it's a synchronous replication system with where all the nodes can act as a master. They are active at the same time. Which means they can take read and write at the same time, all the nodes. Unlike the classical master-slave replication that MySQL provides, where writes are expected to be sent to master only, and reads can be done from master as well as all the slaves. And it also provides true parallel replication capability, as well as a look and feel where a client can directly connect to any of the nodes and like a standalone server. So there won't be a difference. And lastly, it's very easy to set up the cluster. So here's a small diagram which kind of depicts the idea behind the MariaDB Galera cluster. So we have, in this diagram, I've shown 3 nodes which are running MySQL or MariaDB server, and they are patched with what is called WSREP patch, which is at the bottom of the cylinder. And so WSREP is basically write set replication. So it's a patch which basically deals with replicating the chain sets which happens on a particular node. And underneath is the Galera replication part, which is provided by a separate library by the name Galera. So what happens is you plug in Galera library to the node to basically make it ready for synchronous replication. Yeah, and once nodes are part of the cluster, they all can accept reads and writes from the client. Okay, so current state of Galera is we provide Galera version alongside all the vanilla server versions. That is 5.5.10.0. Both are GA, and they usually come a couple of weeks after the vanilla server version. So the latest one is 5.5.43.10.0.19 Galera. And in 10.1, which is right now beta, we just released 10.1.5 sometime back. So what we have done is we have merged the changes from the Galera tree and the server tree. So it's just in one tree now. So if you download the 10.1 packages, you can even make it part of the cluster, unlike the previous versions where the 2 trees were different. And that's why we had to roll out different packages for Galera and non-Galera server. And yeah, so with 10.1, it's just one package, one server package which can basically be used in cluster as well as non-cluster applications. Yeah. And then we provide packages for all major distributions. For example, APT-based, YAML-based, and OpenSUSE stuff. So I'll quickly dive into how to set up the cluster. And while going into all these steps, I'll try to highlight the important stuff that we need to keep in mind while setting up the cluster, running the cluster. Now, so these are the important settings which we must set in order to get the node into the cluster. So the first one is WSREP provider. It's basically the Galera library that needs to be plugged in order to make that node capable of doing synchronous replication. So the first library, libgalera.ssm, is the .astro library that basically provides the synchronous capability, replication capability. And if you just do not provide this, like set it to none, then the node itself will behave like a standalone MariaDB server. So it won't have any of these. So yeah. And the second is WSREP cluster address. So this is another important option or configuration, which basically tells that where should this node connect to. So if you already have a cluster set up and you want to make a new node join the cluster, then all you need to do is pass the IP address of any of the nodes which are already part of the cluster to this new cluster, and it will join that cluster. But let's say if you want to start a new cluster, then this should be empty, or there's a format, just gcom, just the scheme, which says that this is the very first node of the cluster, and it will not join any of the cluster. So, which is called bootstrapping, basically. So you bootstrap a cluster by making WSREP cluster address point to an empty address, that's it. And then from there on, new cluster can join by pointing to the IP address of the first one, and so on. And replication, the binlock format has to be row. So if you're aware of MySQL replication, there are essentially two formats that MySQL supports. One is row-based replication, and second is statement-based replication. In row-based replication, we basically have the updates, actually, the change set transferred to the other nodes. In statement-based replication, we just transfer the statement, the actual command that was executed on the master. So the problem with the statement-based replication is there is no information about the key and all those stuff. So that's why Galera cannot replicate it properly, because Galera has to do some sort of certification to make sure that this particular command or the changes do not conflict with the changes on other nodes. And that's why row-based replication is mandatory on the cluster setup. And then comes default storage engine as InnoDB, because InnoDB is a transactional storage engine, which means you can roll back the changes if a conflict happens. For example, if two clients are sending changes to two nodes which are conflicting, then logically one should win and the other one should roll back in synchronous replication setup. And that's why we need a storage engine with transactional capabilities. So currently in MariaDB MySQL world, InnoDB provides that. There are other storage engines, but at the moment, Galera only supports InnoDB. Another interesting thing is the number of nodes has to be odd. Odd as in, to avoid a very important problem called split green. So what happens is in a cluster environment, let's say a network partition happens and the entire cluster breaks into two parts, such that both end actually thinks that they are into majority, and then they both will start accepting changes. while being disjoint, which is bad actually, because now you have two sets of data. So that's why it is recommended to have odd number of nodes in your cluster, like 3, 5, and so on, to avoid split brain. And if you're pressed on the hardware resources, then there's something called Galera arbitrator, which can be used as one of the nodes. So it's a stateless node, more like a dummy node, but it will avoid the split brain situation. And so once you have that, so now in order to bootstrap the cluster, as I mentioned earlier, what one has to do is, like, there are a couple of options. If you have installed MySQL or MariaDB as a service, you have to just run it with the bootstrap command. Or there is an option called WSREP new cluster. Or the third one is set the WSREP cluster address to gcom, that is empty scheme, with no IP address, because obviously it's the first node, so it doesn't have to connect to any of the nodes. So using any of these three commands, you can bootstrap the cluster, and later other nodes can start joining it. Now, with the gcom empty, that is empty scheme, what happens is, if you leave this thing in my.cnf, and let's say down the line you restart your cluster, after reading this option, the node will bootstrap itself again. So it is not recommended to leave this option in my.cnf file, because if you restart, it will bootstrap a new cluster. So yeah. Now, once the first node is up, what happens is, when you make other nodes join the cluster, it has to do something called state transfer, as in transfer the data from one node which is already part of the cluster to the new nodes. So, which is the donor and joiner thing. Now, okay, in Galera cluster, there are two methods of transferring the state. The first one is snapshot state transfer, which is the transfer of the complete state, the entire database from one node to another. And the second one is incremental state transfer, which is just the transfer of a portion of the entire state. So I'll cover both in detail in the coming slides. So in snapshot state transfer, basically it's done by a bunch of scripts which are provided in the server package. So these scripts uses different tools like rsync, then Percona extra backup, and MySQL dump to transfer the state. So for example, rsync, what it does is, it will grab the entire data directory of the donor node and copy it to the joiner node. So these are different methods which can be used. They all have slight differences and different requirements. Then, so these scripts are written based on something called SST, Snapshot State Transfer API, which means if these doesn't fit your requirement, you can even write your own script to do this. And the last one is, there is an option to basically make Galera pick one node, or force Galera pick one of the nodes which is already part of the cluster. Let's say you have 3 nodes, one of them is quite busy. Then you can make Galera pick one of the non-busy ones to do the state transfer. Yeah, so the third option is basically to do that. And now moving on to incremental state transfer. So what happens is, let's say there was a cluster with 3 nodes. One of the node was taken down for some time, say for routine maintenance or something, but it still had that part of the state. Now, by the time it joins again, it will have a portion of the write sets missing, actually, not the entire state. So in that case, one can do, or Galera does incremental state transfer. That is just the missing write sets are transferred, not the entire state. And that's what incremental transfer is about. So how this happens is, all the nodes they maintain the changes in something called Gcache buffer. It's a circular buffer on all the nodes, and they are all tagged with a sequence number. When a node rejoins, the other donor nodes basically check if they have the difference or the rest of the change sets, and then they will just send the delta to this joiner node and not the entire state. So this kind of optimizes the whole operation or even improves the performance of a node joining again back into the cluster. And so moving on to schema upgrades. So during the lifetime of an application, we need to change the schema over the time. So in a running cluster, it becomes important on like how do you upgrade the schema. Because so what happens is Galera provides two methods, two styles of upgrading the schema. One is total order isolation, and then RSU or rolling schema upgrade. So these two have their own pluses and minuses. Total order isolation is the default method. So what happens is master node basically during the parsing stage detects the DDLs or schema changes and then sends this DDL to all the nodes in the cluster and make sure that the DDL executes in the same slot on all the nodes, that is at the same time, in order to maintain the total order. And because it's sending this statement, it uses statement-based replication format for this particular task. It just replicates the command that was the DDL command that was executed on the initial node, on the first node which has got this particular command. And rolling schema upgrade is a different method where the node which gets the DDL command basically is desynced from the cluster, and then the change gets applied on that particular node only. Now, so I'll talk about the benefits of this just in a bit. So the node gets desynced, and then the execution of the DDL statement happens on that particular node only, and it doesn't get replicated. And after the DDL operation is over, the node gets synced back, and the changes which has happened in the rest of the cluster are replicated to this node again. Now, because of this, the DDL has happened only on one of the nodes, so which means we have to manually go and update the schema on all the other nodes in the cluster one by one. Now, the plus point is, let's say you have a DDL which may take a long time. So with the previous option, that is total order isolation, the entire cluster will stop actually during the operation of the TOI of the DDL. So for long-running DDL operations, it is recommended to use rolling schema upgrade. And if you have a smaller or the usual DDLs, then the default should be fine. And one negative part of the rolling schema upgrade is that changes should be backward compatible. So I have shown an example here. Let's say you have a table and your application is doing inserts on the table, and then you need to add a column to the table. So in rolling schema upgrade, if you run the first alter table, which is essentially inserting a new column between the two existing columns, then the changes or the inserts which happen after that will start breaking actually on this cluster, on this particular node, because this change is not compatible with the current inserts which is happening. So that's why we have to keep in mind that the schema changes has to be backward compatible. Right, so what happens is in Galera, the replication of write sets happens over a different port. Now, if you want to encrypt that particular communication, Galera provides us some options to basically encrypt using SSL. So these are the options which you can use to encrypt the Galera communication or the chain sets which are being replicated by Galera. One important thing to keep in mind is that the certificate and key values has to be same on all the nodes. So yeah. Now, said that the IST or incremental state transfer traffic is basically encrypted too because of this options. But SST, the last line, it's not very clearly visible, but the snapshot state transfer is not encrypted as part of this because that particular task is being done by different scripts, which are actually logically outside the Galera control. So that traffic is not encrypted. But IST and rest of the traffic can be encrypted using these options. Now talking about SST scripts, one of the methods which is there called SST extra backup. So that has some options to encrypt the SST traffic as well. But other two options like rsync and MySQL dump still doesn't have any option in which you can enable the encryption of SST traffic. Yeah. So now when the replication is happening, there is an option to enable the replication or applying of the write sets in parallel by using an option called WSREP slave threads. So which means the write sets can be applied by on the receiving node, which basically improves the performance. But there is a limit on how many threads, or these are called threads that you can use. So the status variable will give you an approximate number, which basically you can use this number to decide how many threads you want on each node. And the maximum number being 4 times the number of CPU cores. So at the moment only EB is supported. So the question is, why is MySM not supported? It's simple because MySM is non-transactional. So in case of conflicts, there is no way to undo the changes, and that's why MySM is not supported. But still, if you want to replicate changes of using MySM tables, there is an option to turn it, but it's experimental. So yeah, so it's essentially not recommended to use MySM in transactions. Yeah. Now load balancing. So when you have multiple nodes running in a cluster, sometimes you can basically transfer or enable the clients to connect to different nodes, so that just one of the nodes doesn't get bombarded with lots of traffic. So there comes balancing, wherein you can use different tools like HA proxy, MaxScale, or Go Galera load balancer, using which you can apply different policy on how to route the new connections. So there are different load balancing policies. For example, read-write splitting, where you can route all the reads to one of the nodes, write to another. So the advantage of read-write splitting is the number of conflicts that Galera gets is reduced because all the writes are going to one of the nodes. So it's more like a master slave configuration. And then it is round robin. You just connect the new connections to other nodes in round robin fashion, or least connected. So least connected is the new request goes to the node with number of connections. So least connected is the default policy in Galera load balancer. Yeah. So there is one more good scheme or topology that you can use to brace for disaster. Here is a diagram which kind of shows the idea. So there is one cluster with 3 nodes. And then the one at the bottom, which is acting as a slave node, basically gets all the traffic which is happening in the Galera application. So the nodes which are connected using red arrows are basically part of the Galera cluster, and the blue arrow is the classical master-slave application. So what we are doing is we are transferring the changes which is happening in Galera to a backup node, which is the slave node. So that acts as a backup node. You can even use it to transfer or cater read requests and all that. Yeah. And by the way, the second node, instead of second node, the slave node, you can even have a cluster actually. So you can create 2 clusters using normal MariaDB MySQL replication too. That's possible. So for the previous scenario, one needs to know about these options which are required. So the first one is logged in, which basically enables the MariaDB MySQL replication. Then log slave updates. Server ID is another key important thing, which is you have to make sure that the server ID should be different on all the nodes. And then GTID, domain ID, it's a new thing that MariaDB replication provides. And then others are some related options. Now, one important thing is to understand the limitations that Galera has is, as I mentioned, that the table should have, all the tables should have a primary key, because that key is used to decide if there is a conflict or not. So based on that key, Galera decides if there is a conflict. And if there is one, then one of the transactions gets rolled back and the winner one gets applied. So that's why you need to have a key. So there's one new option which we have introduced in 10.1, which is InnoDB force primary key. So using this option basically makes sure that you cannot create a table without a primary key. So, and then as I said, InnoDB storage engine is only supported, and there is also a limitation on the transaction size. So by default, it's 1 gig. Troubleshooting, yeah. So we briefly talked about split brain, where so split brain can be basically avoided by having odd number of nodes. Yeah, I think I had a mistake there. So by having odd number of nodes, then or using Galera arbitrator. Right. So another problem that comes in MariaDB Galera cluster is multi-master conflict. So I've been talking about the conflict. So conflict is basically when same row is being updated on multiple nodes at the same time. So this happens because of the design that Galera uses, which is optimistic concurrency control, where we go with the expectation that conflict will not happen. But if it happens, then one of the transaction is chosen as victim, and it's rolled back. So yeah, with a deadlock error. So in order to circumvent that, there is an option called WSF retry autocommit, which can be set to a number so that Galera will automatically try to run that particular command again if it fails. And there are some status variables which can be used to monitor multi-master conflict. So which gives you the number of conflicts happening on each node. So based on that, you can even find out the hot tables. And yeah. In case of conflict, what happens is Galera dumps the write set into a file with this particular format, GRA number and log. So this using this file, you can even inspect at what was the actual write set which conflicted and get the details out of it, as in what was the table which on which the query was executed. In 10.1.4, we have added another version of log file, which basically is self-sufficient because the previous version did not have the bin log header. So one has to apply the header before before inspecting it. And then you can inspect the log file using a tool called MySQL binlog. Yeah. Now, another part of troubleshooting is how to detect slow nodes. So there are some important status variables which basically gives some information on which node is the slowest or slow in the cluster. So because it's a synchronous replication, the slower node can cause the replication, the entire cluster to become slow because it has to keep up with the changes. So in order to detect that you can check the WSREP flow control send status variable and the local receive queue variable. So these two gives an idea on the bigger the number, which means the slower the node is. It is not able to keep up with the actual traffic. Yeah, and the upper limit and lower limit basically gives an idea on when does the flow control kick in and when does it get released on a particular node. Yeah, so just a couple of months back, there was a user who pinged on IRC asking about this question. So the question was, he had a node and a cluster, and then standalone server. Now the server was taking new updates, but cluster was set aside. Maybe it was a backup kind of thing. But the new node had newer data, as in it was active. So what he did is he got this node and attached as a joiner to the rest of the cluster, thinking that the cluster will get all the updates. But what actually happened is it happened the other way, and the node itself kind of downgraded, as in all the new changes were lost. So yeah, so that's the thing. The idea is joiner will always receive, or the node which is joining the cluster will receive the changes and not the other way. And that's why his new node basically lost some of the contents, the latest changes, when it joined to the cluster. Another pitfall is your application should be aware of the fact that the auto increment will not be sequential. And the reason being, in Galera, in order to avoid conflicts, all the nodes have different auto increment values actually, so that there won't be conflict. And that's why because of the different auto increment settings, the resulting auto increment values are not sequential. Another pitfall is one has to make sure that all these settings are close to each other for all the nodes. For example, the SST method or SSL settings, which we discussed before, should be same on all the nodes. Now, talking about SST methods, as I mentioned, SST basically taken care by scripts. So each script has two roles basically to play. One is the joiner role and donor role. Now, if we have two different scripts running on two different nodes, they won't be able to communicate properly. That's why one has to have same SST methods and other setting across the cluster on all the nodes. Yeah, so that kind of concludes what I have to say about Galera. And so MariaDB project, we have the source code available on GitHub, and the documentation is there. Besides, you can report bugs, you can discuss new ideas or issues on the mailing list. You can even chat with us on MariaDB, on Hash Maria channel on Freenode. That's it. Yeah, so questions? Yeah.
Okay, so I had a question about the online team, right? So in MySQL 5.6, right, there are some idle tables which can be run online. Okay. So how does that interact with PC? So if I'm running online idle table,
okay,
and I run it in total order isolation, my server, my cluster will just work fine.
Yeah.
Online the whole cluster, or
I think it will work fine, because one thing is Galera makes sure that the alter table itself happens in the same slot. That is, on all the nodes, it will happen at the same time. And by online, it also means that it will, while the alter table is in progress, it will keep accepting the changes.
So it's online right in the server, but that's total order of isolation means like make sure everything by this point
is done right.
They execute online, they execute at the table, and until that is done, nothing else is executed, and then they restart everything, and then they allow everything else to execute. If that's the case, then online
doesn't make sense.
Tables wouldn't be really online cluster, right?
Right. Yeah. Okay, so I'll have to check. So what you're saying is because alter table happens in total order, so it basically freezes rest of the changes. Okay, but I think the alter table itself returns to accept.
Online, then it comes after either table is completed.
Okay. So
now you can write to that table while it's running.
Right. So during that operation, the nodes will not accept new connections or new changes to that table. Okay.
Okay. Yeah. So what they're saying is the point is if even if you have a
online operation.
5.6, right? The same online by
yeah.
PC, right? Or
right. Okay.
So let me ask you another question. So why do you use Galera cache for SSD and not the binary logs, which seems to have the same data?
Okay, so I think because of the ordering, so Galera maintains its own order, and the Galera cache itself is maintained by the Galera library and not by the server. So I think it's mostly the ordering. I mean, if you look at the replication state machine, the replication state machine tells that all the nodes should have a log, and that log should be essentially the same. So that's why I think Galera maintains its own cache for this particular purpose. But why it cannot do using the usual binary log, I'm not sure. But yeah.
Okay. Well, I was just thinking that you guys doing a deeper integration. That was kind of a natural thing, right? Instead of right now, the Galera you show to you. Load your data, not just 2 times, but 3 times, right?
No, but the thing is, it's a circular cache. It's not the entire binary log.
I know, I understand, but if you look at that stuff, cache is large, right? You will be stored in the database, logged in the
InnoDB, Binlog, and Galera class.
Wow.
Yeah. Good question.
Okay, let's throw that one. I'm more view on Dave now. So how is Galera technology different from MySQL group?
I don't really know a lot about the low-level group replication.
Well, for one, this doesn't need parsing.
We've walked back away from parsing, so.
Oh, I see.
So both are based on the same paper, I guess. So both are based on the same research paper, but MySQL group replication uses CoroSync, and Galera has its own implementation of group communications.
I think they just mentioned what they.
They're going to get away from parsing.
Oh, is it? Okay. Okay.
Okay. And will MySQL group replication support with connector backup for replications?
As far as I know, but I haven't gotten to play with it yet, so I can't tell what it breaks when it doesn't.
Okay.
Backups don't need backups.
Well, I mean, the answer to the provision is you get, well, let's get a provision on the backup. Yeah. Because it's like the MySQL way to say, hey, you just have to make sure you have a cluster of 5 nodes which are absolutely the same, and then you just switch it and that's not replicate. That's it. That's quite powerful cluster, right? It's supposed to be self-healing, right? And all of this stuff.
Well, we need that interest with the call revenue.
Oh, yes.
Started number one, we wait up there.
Okay. More questions?
Oh, yes. I don't have a kind of first question. So you say you cannot ever have a cluster with an even number of nodes, right? But then I'm thinking about we typically have nodes leaving or joining cluster one by one, right? So for example, I have 7 nodes, one of them died, now I have 6. Oops. That doesn't mean that I cannot ever run the same cluster of Galera because there's always going to be certain times the number of nodes is even.
Yes, I mean, when it comes down to even, then that problem is there. As in, the DB or the person managing the cluster has to make sure that he has to either add a Galera arbitrator, because when the node number comes down to an even, there is a possibility that network partition can happen. And in that case, it's the worst case scenario where both the part will think that they are into, they have the quorum, and they will basically accept changes.
Wait, but that's kind of strange. Because shouldn't they both think what they don't have a quorum? In this case, because it's typically n divided by 2 plus 1, right?
Mm-hmm.
Part of the quorum.
Yeah. So the quorum, I'll have to look at the formula. So, I mean, it basically says that.
Okay.
Depends on which side of the network split the node that went on offline originally was on.
But well, I think it's not about the node goes online, right? Let's say I have 4 nodes, right, in 2 data centers. The link between those data centers would die, right? And typically in this case, you have both data centers say, oh shit, no quorum, right? I still quorum. And in this case, it does make sense to have a Galera arbiter, right? What we'll say, right? Let's say 2 data centers with 1 extra node in this case. So if a link goes between 2 data centers, then one of them which has a Galera arbiter survives, right? But it also, there's other ways to solve it. For example, I may have 3 data centers with 2 nodes in each, and then if one of the data centers goes dark, then well, who cares? How it to communicate and continue to work.
We got local data center network.
What's that? Yeah, I mean, it's 3 of them, right? Okay.
Yeah. So I think.
Well, but the cluster will, in a case where there's a split or a node crashes, there's now an even number to be done on. It will still operate. There's some information about how many should be in the cluster.
Sorry.
In a degraded state, where you still have the majority of nodes online and able to mutually communicate, the cluster will still operate because.
Yeah. So I think.
I think the problem also with these sort of setups, even even number of nodes, is that the probability, I mean, unless you, the case you just described with one data center, the probability of failing zero, but the probability is even between two links.
Yeah.
Right? With the even number, the chances you'll have a cluster outage are greater because the chances of the right number going down are.
Okay, but I mean, in all likelihood, right, you're saying, okay, I have, let's say, 5 nodes, right? Well, the chances are that going to 3 of them going to go down, right? Right? So yeah. My point in this case, if you have a lot, let's say, I would say 2 nodes is a very good choice, right?
Right.
Now, if I have a 6 nodes, then that's reasonable.
Right. But is 6 nodes actually better than having 5 nodes on your eyes?
Well, I mean, in terms of 5 or 6, I think in this case it becomes not a question about the habitability anymore, but a question about the growing cluster capacity. I mean, in terms of the availability, you probably don't really need more than 4. Because 4, that means one of them dies, and you still have a 3 node, which is reasonable cluster. Another one can die, but 2 nodes still can work with this and becomes equal, right?
Yeah.
In this case. And then you have a logic cluster, 7, 8, 10 nodes. That is the one to scale degrees, because you have a lot more, right? Does that make sense?
Yeah. Okay. That's it.
Yeah,
Thank you.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Insight into stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time? Record this data for later analysis. Enter the new way to see what's really going on under the hood. Dashboard can visualize the status of all your systems, providing you with a bird's eye view of your entire fleet. You can sort by CPU, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available in the Network tab, and disk writes and free space on the Disks tab, while the Processor displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure. And without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.